Chemistry important notes for second year students. For exams preparation. Chapter number 1. Hue number 1. Justify that ZeNO is atmospheric in nature? Answer. Zinc oxide, a white powder at room temperature, isn't something you'd normally find floating around in the air we breathe. While natural events like forest fires and volcanoes can create tiny amounts of ZeNO as they vaporize materials containing zinc, these quantities are very small. ZeNO is more commonly associated with industrial processes, pigments in paints, and even sunscreens that utilize its ability to block ultraviolet rays. In essence, ZeNO exists in our world, but it's not a major player in the overall composition of Earth's atmosphere. Hue No. 2. Although both phosphorus and sodium are present in the same period of the periodic table, yet their oxides are different in nature. Na superscript 2O is basic, while P superscript 205 acidic in character. Answer. Electronegativity difference. The key factor lies in the difference in electronegativity between the elements and oxygen. Electronegativity is the tendency of an atom to attract electrons towards itself in a bond. Sodium, Na, is a metal with a low electronegativity. Phosphorus, P, is a nonmetal with a higher electronegativity compared to Na. Bonding type. This difference in electronegativity influences the type of bonding formed with oxygen, O, in their oxides. Na2O. Sodium oxide, due to the significant difference in electronegativity, Na readily loses its single valence electron to oxygen. This results in ionic bonding between Na plus cations and O2 anions. When Na2O dissolves in water, it releases these O2 ions which readily react with water molecules, H2O, to form hydroxide ions, OH, a hallmark of a basic solution. OP4010, phosphorus pentoxide. More accurate formula. Phosphorus has 5 valence electrons to share. While some ionic character can be present, the bonding in P4010 leans more towards covalent due to the closer electronegativity values of P and O. This covalent PO bond can be polar, with oxygen attracting the shared electrons more strongly. When P4010 reacts with water, these polar covalent bonds can be broken, and the molecule can accept protons, H+, from water, behaving as an acidic oxide. So, the acidic or basic nature of the oxide depends on the ability to donate hydroxide, OH, ions, basic, or accept protons, H+, acidic, in water. In this case, the greater electronegativity difference in Na2O leads to ionic bonding and a basic character, while the more covalent nature of P4010 allows it to act as an acidic oxide. Hue No. 3. Why the ionic radii of negative ions are larger than the size of their parent atoms? Answer. Negative ions become chubby because the extra electrons they gain repel each other, needing more space around the nucleus compared to their parent atom. Hue No. 4. What is electron affinity? Why is the second value of electron affinity of an element usually shown with a positive sign, / what is electron affinity? And give its trend in periodic table? Answer. Electron affinity tells you how easily an atom can grab an extra electron, become negative. It's like gaining energy, negative value, when the electron fits in nicely, but sometimes it takes energy, positive value, to squeeze in another. Generally, elements on the right side of the periodic table are better at grabbing that first electron, increasing across a period. But as you go down a column, adding electrons to further out shells makes it less attractive, decreasing down a group. The values you usually see are for the first electron. Adding a second electron is often trickier, positive value, due to repelling forces between the electrons. Hue No. 5. Why metallic character increases from top to the bottom in a group of metals? Answer. Metallic character refers to a set of properties that define metals, like conductivity and malleability. A key factor influencing this character is how easily an element loses its outermost electrons, valence